In the present video, we will discuss the pneumatic comparators. A pneumatic comparator is a measuring instrument that uses compressed air to compare the dimensions of a component with a standard size. So let's see the working principle of the pneumatic comparators. Pneumatic comparator works on the principle that small changes in the size of a part cause changes in air pressure or airflow which can be measured accurately. So this is the schematic representation of the working principle. So when the air is passes through the calibrated orifice and then through the small gap between the measuring head and the workpiece. So first compressed air is passes through the calibrated orifice and then through the a small gap. So this is the small gap between the workpiece and the measuring head. Then if there is any change in gap, then it will be effect on the change in air pressure. It will be results on the indication of the deviation. So let's consider part is the smaller than the standard size, then gap is increases, then pressure is decreases. So this indicated the indicator moves to the left side, which is the negative deviation. Similarly, part is equal to the standard size, then gap is same only normal condition. Then there is no change in pressure. Obviously indicator at 0, then no deviation. So let's consider part is the larger than the standard size, then gap is decreases, then pressure increases. It will be indicator moves to the right side, which indicates the positive deviation. So this is the working principle of the pneumatic comparator. Let's see the briefly working principle of the pneumatic comparators. A pneumatic comparator measures very small dimensions differences by using air pressure instead of direct contact with the workpiece. And it works on the principle of Bernoulli's theorem. So first step is air supply. Compressed air is supplied at a constant pressure. The air first passes through the controlled jet capital C into the intermediate chamber. So in the schematic you have to see. So here compressed air is supplied at a constant pressure. Then this compressed air is first passes through the control jet. So this is the control jet. Let's consider the capital C. Then it will be passes to the intermediate chamber. So this is the intermediate chamber. So next step 2 is air reaches the gauging jet. So from the chamber, from the intermediate chamber, the air flows through the gauging jet. Let's consider the capital G. So here, so air is next to passes from the intermediate chamber to the gauging jet. Then the workpiece is placed to close to this gauging jet. Here we are placing the workpiece which is very close to this gauging jet. So step 3 is gap controls the airflow. Let's consider a small gap exists between the gauging jet and the workpiece. This gap determines how easily the air can escape. So let's consider the case 1. Gap is small, then less air can escape. Then air gets restricted, which has to be result in the pressure inside the chamber increases, which has to indicate the manometer shows a higher reading. Second case, if the gap is large one, so air escapes easily, then chamber pressure decreases, then the manometer shows the lower reading. So next step is the measurement. The pressure change is proportional to the change in the gap. The instrument is calibrated So the pressure reading directly indicates the dimensional error of the workpiece. So this is the working principle of the pneumatic comparators. Let's see the applications of pneumatic comparators. The first application was the checking of the bores of motor car cylinder blocks. Now it is almost used in production shop for this purpose. And pneumatic comparators can measure several features simultaneously such as the length, diameter, squareness, parallelism, taper, concentricity and the straightness. So let's take the example. While inspecting the bore of an engine cylinder, the instrument can be check bore size, taper, straightness, camber all in a single setup. Next we have to discuss about the advantages of the pneumatic comparators. So pneumatic comparators are the cheap and simple to operate. And pneumatic comparator free from the mechanical hysteresis and the wear, because here there is no contact parts. So there is no wear and the hysteresis. And pneumatic comparators magnification as high as nearly it is the 10,000 magnification can be obtained. Next one is the advantage. The gauging member is not in a direct contact with the work. And moreover, so in the pneumatic comparators, indicating and measuring is done at two different places. On pneumatic comparators, tapers and ovality can be easily detected, and moreover these are the ideal to be used on shop floor as itself cleaning due to the continuous flow of air through the jets. So these are the advantages. Let's see the limitations of pneumatic comparators. Pneumatic comparators are very sensitive to temperature and humidity changes. And next one is the accuracy may be influenced by the surface roughness of the component being checked. And next limitation is pneumatic comparators requires different gauging heads and needed for the different jobs. And next one is the auxiliary equipment such as the air filters, pressure gauges and regulators are required. And last limitation is the non-uniformity of scale is a peculiar aspect of air gauging, as the variation of back pressure is linear over only a small range of the orifice size is variations. So these are the limitations. Next we will discuss the Solex gauge or air gauge. What is a Solex gauge? A Solex gauge is a pneumatic comparator or air comparator which is used to measure very small dimensional variations accurately by using air pressure. It was commercially introduced by Solex Air Gauges Limited, and it is mainly used for internal measurements, especially holes and bores. And by changing the measuring head, it can also be measure the external dimensions. And moreover, Solex gauge is uses a water manometer to indicate the back pressure. Next we will discuss the construction of the Solex gauge. So this is the schematic representation of the Solex gauge. Here you have to observe the different parts. So let's see the construction. A Solex gauge is consisting of the compressed air supply. So here it is the compressor which has to be produced the compressed air. And next part is the controlled orifice. So it is the controlled orifice. And next one is the measuring jet. So this is the measuring jet or the gauging head. And next one is vertical water cylinder. So it is the consisting of the vertical water cylinder, and it is consisting of the dip tube. So this is the dip tube. And next part is the water manometer. So this is the water manometer. And next part is the calibrated scale. So here it is consisting of the calibrated scale. So these are the construction of the Solex gauge. Next we will discuss the working principle of the Solex gauge. So first step is air supply. So compressed air enters the instrument. The air pressure is kept constant by using a water cylinder and the dip tube. So here dip tube has to be ensure a steady air pressure for accurate measurement. And second step is constant pressure formation. If the supplied air pressure is higher than the required, excess air escape as bubbles through the dip tube. So therefore, only the required constant pressure reaches the measuring system. So next third step is this air, so compressed air passes through the measuring jet. So the constant pressure air passes through the controlled orifice and then through the measuring jet. And moreover, the workpiece is placed near the measuring jet. So in the third step, air passes through the measuring jet. There are the two cases. Case 1 is no restriction, which means there is the large gap is exist between the workpiece and the measuring head. Then air has to be escaped freely and back pressure is low. In this regard, water level in the manometer remains almost the same as in the cylinder. Next second case is restriction. If there is the small gap between the workpiece and the measuring head, then air cannot escape freely. So in this regard, back pressure is increases, then water level in the manometer has to be false. So next step is the reading the dimensions. The change in back pressure is proportional to the change in the size of the workpiece. And moreover, the calibrated manometer is directly shows the dimensional variations. So this is the working principle of the Solex gauges. So let's see the applications of the Solex gauges. A Solex gauge is used to measure bore diameter, internal diameter, moreover external diameter with suitable attachments, concentricity, roundness and the taper of the holes. So let's see the how to find the concentricity. So first we have to insert the measuring head into the bore, then rotate the workpiece slowly, then observe the manometer reading. In this regard, reading remains a constant mean hole is perfectly round and concentric. If the reading is changes, this indicates the hole is not concentric. Similarly, Solex gauge also find the taper. Let's see the how to find the taper. So first I have to measure the bore at different positions along its length. Then compare the readings. If the same reading is everywhere mean, so given workpiece is there is no taper, and the result in the different readings mean bore has a taper. So let's see the advantages of the Solex gauge. So these are the very high accuracy, no damage to the workpiece because there is no physical contact. And next quick measurements and suitable for the mass production, and it can be measure very small dimensional variations. And small limitations also there for the Solex gauge. Requires clean and dry compressed air, measures only small dimensional variations. Initial calibration is necessary and it is not suitable for the rough surfaces. So these are the advantages and limitations of the Solex gauge.